from, and thanks for attending the Introduction to Azure Infrastructure Services webinar. My name is Eric Boyd. I'm an Azure MVP, a Microsoft Regional Director, and the founder of ResponsiveX, where we help customers run workloads and develop applications in Azure. And I'd like to welcome you to Azure, and more specifically, Azure Infrastructure. In today's 60-minute webinar, we're going to explore the infrastructure services available to you in Azure. We'll take a lap around the core infrastructure services, including compute, storage, and networking. You'll see how Microsoft has integrated management, operations, and security into the foundations of Azure, along with a massive number of independent audits and compliance certifications. And we'll also look at billing and how you can manage your cost and make the most effective use of Azure. The session will include a mix of content explained through slides and visuals and live demos of the Azure capabilities. Now, before we dive in, I'd like to point out some resources that we have for you. So on the right side of your webinar console, there are links to several resources that we believe will be helpful as you get started with Azure. I'm also going to leave a few minutes at the end for Q&A, but if you have any questions during this session, please enter them into the Q&A window. We have a few Azure technical experts with us today, and they would be happy to help you with your questions. The session's also being recorded, and the recording will be sent to you by email within 48 hours. Now, before we get deep into Azure Infrastructure Services, let's talk about the cloud at a high level. The Microsoft Cloud consists of three major cloud services: Office 365, which provides productivity services and capabilities including content authoring, messaging, and collaboration; Dynamics 365, providing business solutions like ERP, finance, and CRM solutions; and then Azure, which provides a platform of services and core infrastructure capabilities for IT organizations and technology teams. Quite simply, Azure is the place where developers can innovate and create solutions and applications using a broad range of services, including compute, data, and even higher-level AI services. And it's also the cloud that technology implementers like system, infrastructure, and network engineers can utilize to deploy custom and pre-built vendor workloads in the cloud. Now, the cloud exists to help you optimize efficiency, including time and effort, speed and time to market, and cost through economies of scale. We're all familiar with our traditional on-premises model, where we are responsible for managing everything in our data centers, from the physical space to the power, cooling, networking, physical services, all the way up through our application stacks. The cloud enables us to delegate the aspects of operating our own data centers, which are highly generalized and commoditized, to a partner like Azure. When we start exploring the cloud, we often start by considering infrastructure as a service, or IaaS. IaaS lets us delegate the responsibility of managing the physical aspects of our data centers to a partner like Azure. So no more managing physical space, air conditioners, cabling, or hardware. Instead, we just let Microsoft and Azure take care of that for us. I like to think about IaaS like the utilities that we consume in our homes daily. We wouldn't think to build a power plant or a water treatment facility in our backyards to provide those core infrastructure services to our homes. So why should we build core infrastructure for our technology services? Infrastructure services and IaaS will be the focus of our webinar today. But you should know that as you move farther to the right, you delegate more responsibility to the cloud provider and you gain more efficiency as a result. For example, in the platform as a service model, you just focus on the apps and data and not operating and managing the virtualized and software-defined infrastructure, which frees you up to do other things. And the panacea of the cloud is software as a service, which includes services like Office 365, Dynamics 365, and others. And in this model, your cloud partner develops and manages the applications and data. You only need to concern yourself with configuration and integrating it with other systems in this model. Azure provides modern infrastructure services for all your workloads, with built-in hybrid support enabling you to extend your on-premises data centers into Azure, and security and management capabilities integrated into the foundations of these services. All of this while being economical and cost-effective. Let's take a deeper dive into these infrastructure services and look at the benefits of the Azure cloud. At the lowest level, Azure is a collection of data centers around the world. An Azure data center is a pretty amazing feat of engineering. They are enormous in size and scale, filled with hundreds of thousands of physical servers, taking up the space of several American football fields, and are highly innovative in design for optimizing maintenance, density, and efficiency. Now, there are a couple of Azure data center designs. One approach consists of servers contained within shipping containers. This enables Azure to rapidly add or replace capacity by simply connecting a shipping container full of servers to power, cooling, and networking, and be up and running in an Azure data center in hours. Now, another approach looks very much like our traditional data centers with racks and racks of servers. However, in the Azure data centers, the racks are pretty uniform and consistent and designed with operational and management efficiency in mind. These data centers are distributed across the planet in 54 regions. Azure has more data center regions around the world than Google and AWS combined. When architecting solutions in Azure, you should choose regions near your users and customers to provide a great user experience and reduce the latency. If you need to comply with data sovereignty regulations and keep your data within specific geopolitical boundaries, you should choose regions within those countries. Partnering with Microsoft and Azure gives you access to one of the largest global networks in the world, backed by over 100,000 miles of lit fiber optic and undersea cable. More than 150 global edge nodes, and more than 60 global content delivery network points of presence. Building on the global Azure region and data center footprint is networking. Your Azure virtual network enables you to define the networking address space in subnets, much like a VLAN in your on-premises network. And then you can firewall and policy north-south and east-west traffic using Azure Firewall and network security groups. If you want to take advantage of Azure's global fiber network and keep your traffic traveling within that network for as long as possible, you can do that with Azure's front door service. You also want to leverage the global edge and CDN nodes, and Azure Traffic Manager and CDN enable you to do just that. As you see, there are lots of robust networking services available in Azure, including Layer 4 load balancers that enable you to route traffic between multiple virtual machines in a cluster or a web farm. There's also Layer 7 application gateways and WAFs that allow you to not only load balance traffic across multiple virtual machines, but also inspect the HTTP packets at the application layer on the way in and out to prevent exploits, including top OWASP attacks. There are also DDoS protection and DNS services available within the Azure networking services. To make hybrid cloud a reality, you need to be able to extend your on-premises network and data center into Azure. There are multiple options for you to achieve this. VPN gateways provide you with the ability to connect Azure via a point-to-site or site-to-site connection. The point-to-site option allows you to create an SSTP tunnel through an Azure VPN client that you install on your workstation. If you want to avoid installing clients, you can extend your network with an IPsec tunnel and create site-to-site connections. If you'd like to move this hybrid connection off the public internet altogether to achieve better reliability and consistency in throughput, you can also get your own dedicated MPLS circuits. You arrange that with your telco and using Azure Express Route service. Azure Virtual WAN is a newer service that enables you to simplify complex multi-site networking configurations that you may have with multiple branch offices and or multiple Azure regions or virtual networks that need to be integrated. Let's take a moment to see some of the networking capabilities in Azure. Let's start by creating a virtual network. I'm in the Azure portal. I'm going to click on the Create a Resource button in the upper left-hand corner. It's going to show me a list of categories. I'm going to create networking services, so I'm going to scroll down to the networking category. I'm going to scroll up to the top of this category and select Virtual Network. Now this is where I can configure my address space and my network in Azure. So I'm going to name it first. I'm going to call it Azure Infrastructure VNet for Virtual Network. I get to define the entire address space that I want to use for this network. So I'm going to use this entire block of addresses. I get to pick the subscription I want this virtual network to reside in. Then I get to pick a resource group. Now a resource group is just a container of multiple resources that I'm using for an app or a solution. So I'm going to call this Azure Infrastructure-RG and press OK. I get to pick the location next. I'm going to choose the East US region. I get to name the first subnet. I'm going to name it public. It's going to be my DMZ, and I get to pick the address range for that subnet. So I'm just going to choose this first 256 addresses for that range. I can also enable some features like DDoS protection. I can choose the tier of that. I can enable service endpoints and the Azure firewall. I'm going to leave those just like they are and press create. It will do a validation. It will start the deployment if everything is good, and it is. So my deployment is now in progress. We can see that by this notification that popped in the upper right-hand corner, as well as the notification pane shows this new notification. Now, it succeeded really quickly, so I'm just going to click the Go to Resource button in that notification pane to take me to my virtual network here in Azure. So we're seeing the configuration of this at the top. We are seeing the address space. DNS is using the Azure DNS service. I don't have any connected devices at this point. It's a brand new virtual network. There's no virtual machines or NICs in this network at this point. But I can click on subnets here and configure the subnet. So I have my public subnet that I created when I deployed. You'll notice that there's only 251 of those 256 IP addresses available, and that's because Azure reserves the first four for the software-defined networking that occurs, and then of course the last IP address is the broadcast IP. So we only have 251 out of that subnet. Now I'm going to go ahead and click the plus sign next to subnet to add another subnet. So I'm going to create my private subnet here. I get to pick the address range again. So there's the 251 plus the 5 reserved Azure addresses. We get the options here to configure network security groups and route tables if we wanted to have user-defined routing going on as well, service endpoints, but I'm going to leave that just like it is and press the OK button. This is going to add the second subnet for us. If we want to create a gateway in this subnet, so a VPN gateway, and we want to have a site-to-site IPsec VPN tunnel from our network on-prem to our Azure network. We can just add this gateway subnet. It will choose the name for us. That's the name it expects, and we can select the address range here, and I'm going to leave it with that big address range. I think we need a /27 by default, but this /24 is plenty, and I can press OK, and it will add the gateway subnet in for me as well. If I go back to my dashboard, I could create another network in another region or even in this region and simulate that site-to-site VPN connection. And so I'm going to just show you one that I've already set up. I have region 1 VNet set up here, and you'll notice I have a few things in that address space already. If I go to the resource group for this, we will see lots of different resources in this resource group. But what I'm looking for is the VPN gateway. So there it is, the virtual network gateway. So I'm going to click on that. Now I've set up this virtual network gateway. It's got an IP address for us to connect to. So essentially this is where I destine my VPN tunnel here in Azure. I have a connection already set up, and that is to a second virtual network that I have. And so you'll see that region 2 connection is connected to a virtual network I have from the East Coast to the West Coast of the US. So I'm just simulating that virtual network connectivity here in Azure. But I have a shared key. The configuration for that is got BGP disabled in this case, but I could BGP these together as well to ensure that I have failover in these connections, which is a common thing for me to do in a geo-distributed scenario or where I have ExpressRoute and I might want to fail over to a virtual network connection with my ExpressRoute circuit. So that's how I set up my virtual network. I can set up that virtual network gateway just like this to connect multiple networks together. My on-premises network to Azure is a common scenario, extending my network into Azure. In this case, I did it just simulating it with 2 Azure networks. I probably wouldn't do that in practice. I wouldn't use the VPN gateway to connect to Azure networks. Instead, there's a capability here in Azure called virtual network peerings, and I can peer those networks together and simply kind of unify them as one network here in Azure. And so that's the way I would commonly do that if I needed to combine 2 Azure networks or peer 2 Azure networks instead of using that VPN gateway and having that hop in the middle. The other thing I want to call out here is network security groups. And so we've talked about firewall rules and policies that we may need to establish within our network to secure the traffic in our network. And we have the ability to do that in a couple of ways. One, there's the Azure Firewall, and the Azure Firewall is really designed for the north-south traffic, the traffic coming into our network from the outside. But we also have Azure Network Security Groups, and that's really designed for the east-west traffic. And so you'll see I have these inbound security rules. I've opened up HTTP. I am using this for the north-south traffic as well. You can do that for sure. And so I've opened up HTTP because I have a web server that this is connected to. And I've also opened up port 3389. In the real world, in practice, I wouldn't encourage you to do that, but I am opening up RDP to the outside world and letting me RDP into this server remotely. So we see that a lot when you're just setting up a server, you don't have virtual network connections in place, that sort of thing. In practice, I would try to get this off of the public internet as much as possible, the RDP traffic, and take it over your internal virtual network connection, a VPN gateway of some sort. Now that we can communicate within the network on an address block and subnet design of our choice securely with hybrid connectivity back to our on-premises data center, and with public endpoints being load balanced across our web farm, we need to consider storing and accessing data. Azure has storage services designed for our infrastructure services, including disks, blobs, and files. Disk storage provides persistent disks that can be mounted to a virtual machine for both the operating system and applications, or additional data capacity that you may need within your virtual machine. Blob storage is an object storage service that enables your applications to store and retrieve files from a centralized storage location via a web API. It's designed for scale and availability and can be accessed from anywhere via HTTP requests. And file storage using Azure Files or NetApp Files brings traditional UNC path storage and shares to your virtual machines in Azure. This is useful if you don't have the luxury of being able to adapt your applications to use the blob storage APIs, but you need to run those legacy applications in Azure. The file storage paths can be mounted and shared across multiple virtual machines so they can share a common storage location. In addition to those core storage services, there are services like Azure Import Export and Azure Databox that simplify and accelerating migrating large amounts of data into Azure, as well as hybrid storage solutions like StoreSimple SAN that allows you to tier your cooler data into the Azure cloud. Azure disks come in several performance tiers to provide you with the best combination of performance and pricing for your workloads. The standard HDD option is the lowest performance tier and also the most economical. It ranges from 500 to 2000 IOPS and 60 megs to 500 megabytes per second of throughput per disk. Now these are essentially magnetic spinning disks. You can jump to solid-state disks with the SSD tiers. The standard SSD tier provides lower latency and 120 to 6,000 IOPS with 25 megabytes to 750 megabytes per second of throughput. If you need faster SSDs, you can achieve up to 20,000 IOPS and 900 megabytes per second of throughput with the premium tier. And the newest, fastest disk tier in Azure is the Ultra SSD disk, which provides sub-millisecond latency, up to 64 terabytes of disk capacity, 160,000 IOPS, and 2,000 megabytes per second of throughput. Now, Azure disks are great for persistent fast storage to local virtual machines, but when you need to share the same storage and files across multiple servers, you must consider file server-like services, like Azure Files, for example. Azure Files is a centralized storage service that provides protocol support for SMB 2.1, 3.0, and REST web APIs. This allows you to connect to Azure Files from your applications using the web APIs, from virtual machines in Azure using SMB, and even outside of Azure from your on-premises machines with that SMB 3.0 support. Let's take a moment to see some of the storage capabilities in Azure. Now that we can communicate with the Azure networking services, and we can store and access data with the Azure storage services, we need a place to host and run our compute workloads. Azure infrastructure services provide us with virtual machines, much like the virtual machines you run in your own data centers. Azure virtual machines run on Hyper-V-based hypervisors, so the same VHD file that you run in your on-premises data center will run in Azure and vice versa. You can run both Windows and Linux servers in Azure virtual machines, and there's a huge gallery of pre-built virtual machine images that you can pick from. You'll find images for things like Drupal, SQL, and even multi-VM solution templates for larger systems like SharePoint or WebSphere. In addition to having lots of options for the virtual machine images, there are lots of size options and workload-specific hardware available. The A series is the original VM size in Azure. It's great for your entry-level workloads. The B series are burstable, meaning they can flex and scale the virtual CPU core. These are great for web servers, small databases, and dev test workloads. The D series are labeled general purpose. They provide a great balance of CPU and memory, and like they are named, are good general purpose VM sizes. If you have compute-intensive workloads, the F series VMs are designed for these workloads. The L series or storage optimized size is designed for low latency, high throughput storage using locally attached NVMe storage. Like the compute-intensive F series, there are also memory optimized sizes, including the G, E, and M series. The NVIDIA GPUs are available in the N series. These are great for AI and rendering workloads. And the H series are designed for HPC compute with InfiniBand and consistent RDMA performance. Let's take a look at Azure virtual machines. Back in the Azure portal, I want to create a virtual machine. So I'm going to click on the Create a Resource button again. And this time I'm going to go into the Compute category. And we'll see lots of different options here in Compute. I'm going to select Virtual Machine at the top. It's going to start asking me for some basic information for my virtual machine. So first, where I want to deploy to, again, my subscription. What resource group? This time I'm going to pick the resource group we added when we were looking at networking. I'm going to name the virtual machine. So let's just call this Web Server 01. I'm going to choose the region that I want to deploy the virtual machine into, and I'm going to choose East US. I'm then going to choose the image that I want to use for the virtual machine. And you'll see that I have a number of options just in this drop-down, but I could just click Browse All Public and Private Images, and that would take me into the gallery of VM images that I could pick from. I'm going to select Windows Server 2019 Data Center Edition. I'm going to click Change Size. It'll show me the list of all the VM sizes that I could pick from. Now, these are just the sizes that are available to me in my subscription and subscription type, as well as the region that I picked. Now, you'll see it's only showing me 13 of the 259 sizes that are available to me, and that's because I have these filters enabled here at the top. If I start removing these filters, the number of sizes increase, and I'll be able to see all 259 that are available to me. You can see we can choose from different CPU configurations, RAM, disk, I/O, and then the price over here on the right-hand side. Now, I'm happy with the default that it's selected for me, the single CPU, 3.5 gigs of RAM, so I'm going to leave it with that size and continue on. Next, I get to configure local admin credentials for this server. I'm going to use a username and password here that's complex and secure, and continue on. But this is just local admin credentials. Once my VM is here, I can domain join this to Windows Server Active Directory or Azure Active Directory as well. Next here, I get to quickly configure inbound port rules. Now, these are those network security groups that we were looking at earlier. And you'll see if I click Allow Selected Ports, this is going to allow me to open up things like RDP and HTTP, HTTPS. Just quickly here. It's not a full list of what we can do for management and configuring those network security groups. It's just a way to quickly do this as we're creating this virtual machine here in Azure. If we click the next button, we were talking about storage just a little bit ago, you'll see this is where we can configure the disk performance capabilities and the storage capabilities of our VM. You'll notice those sizes that we talked about: standard HDD, that magnetic spinning disk, standard SSD, premium SSD, and then this ultra disk capability. Now, this is not available to me because of the location that I selected as well as the VM size, so that's why it's disabled here. But I'm going to go ahead and select premium SSD for the OS disk. I can also attach additional data disks, so I can just click Create a new disk here, name my disk, choose if I want it to come from a snapshot or a blob. In this case, I just want an empty disk. I'm going to choose a 1 terabyte size premium SSD, press OK, and I now have an additional data disk attached to this VM. I'm going to click Networking, and this will allow me to configure the networking for this virtual machine. I'm going to put it in the virtual network we configured and created a little bit ago. I'm going to put it in the private subnet, not the public subnet. I'm going to put it in, I'm going to give it a, actually I'm going to change that. I'm going to put it in the public subnet, and I'm going to give it a public IP address. And then I can configure network security groups, inbound port rules. We've already selected RDP and HTTP. And I could also configure a load balancer here, but I'm going to go ahead and just click Next and go to Management. And this is where I can configure additional things like boot diagnostics and OS diagnostics. And there's the storage account that those will go into. I can select whether I want it to automatically shut down at periods of time. I don't want an auto shutdown rule enabled. And I can also enable things like backup right here. I'm going to click Next and go to Advanced Settings. This is where I can install additional extensions that I might want to use to run PowerShell or some sort of shell script on the box. And then you'll also see I have additional options for selecting the VM generation as well for Gen 1 or Gen 2. I'm going to go ahead and click Review and Create and go to the summary of what I'm about to do. So it shows me I'm going to create a standard DS1 v2 VM. It's going to cost me 7.3 cents an hour. It makes sure that my settings are going to work well together, so it does a validation on those. It also makes sure that I have permissions to do this, that I'm adhering to any policies that are set forth by my organization, that sort of thing. So I'm going to press Create and start the deployment process for this virtual machine. We'll notice in the upper right-hand corner, the deployment's in progress. We see the deployment screen right here, and it will show us the progress of this virtual machine deployment. Now, a virtual machine is finished deploying. We can see that our deployment's complete. We can click into the deployment details, and there is the virtual machine resource. If I click into that, this will take us to the details for our virtual machine. The configuration at the top, it's in the running status, is in the East US region, the operating system, size, public IP address. I'm going to copy that public IP address to my clipboard. And I'm going to scroll down. We can see the virtual network and subnet configuration here that we configured. But I'm going to scroll down a little bit, and this is where we can see charts of the utilization. These come out of Azure Monitor. We see CPU, network, and disk I/O right here. We also see across the top a strip of buttons that let us kind of manage the life cycle of this VM. It's started already, so that start button's disabled. We can restart that, stop it, capture an image of it. We can press the connect button here as well and start a remote session into this virtual machine as well. So we see RDP is selected because it's a Windows server. We can download an RDP file to our local system. So I'm going to save that, and then I'm going to open it. And this will launch a remote desktop session right into this virtual machine running in Azure. So I'm going to choose the account that I created. When I created this virtual machine, and in seconds I will be remoted into this Windows Server 2019 Data Center Edition VM running in Azure. So I can manage it just like any other virtual machine, whether it's in my data center, a colo, or a third-party cloud provider like Azure in this case. Now back over in the Azure portal, on my dashboard, you may have noticed a tile that says Webinar Ubuntu 01. I have an Ubuntu Linux VM running here in Azure. I'm going to click into that tile. We'll see the same experience here in the Azure portal. We see the same configuration information at the top, and then down below we see the same charts to show us that utilization and health information. I'm going to click the Connect button, and this time, instead of showing me the RDP tab, it will show me the SSH tab. And it does that because it's a Linux VM, and it knows we're not going to RDP into that. Instead, it shows me this SSH command that's just formatted for me. I'm going to copy it to my clipboard. And I'm going to paste that SSH command into the terminal. And I'm going to enter in my password for this VM. And I'll be SSH'd into that Ubuntu Linux VM running in Azure in no time. And I can run commands like top to get a list of running processes as well. Let's take a look at Azure virtual machines. Robust and flexible compute, storage, and networking services are at the core of Azure and are the core of the Azure infrastructure services that enable us to run our server-based workloads in Azure. Now, when I say there are sizes and services for every workload, I mean it too. If you need a single CPU core, no problem. If you need 480 CPU cores in a single virtual machine, Azure has that too. Up to 24 terabytes of RAM on a single VM and 64 terabytes of disk, providing 160,000 IOPS and the fastest networking with 30 gigabits per second Ethernet and 100 gigabits per second InfiniBand support on the H series VMs. Now, a lot of people think about Azure as the Microsoft and Windows and .NET Cloud. And while you can run those workloads very well in Azure, Azure and Microsoft is much bigger than that. Microsoft loves Linux. You saw us set up an SSH into a Linux VM running in Azure. And about half of all VMs running in Azure today are Linux. But it's not just Linux workloads. Microsoft loves open source. Microsoft is the single largest contributor to open source, with more employees actively contributing and more contributions than Google and even Red Hat. And here's an example of open source workloads that are fully supported and run in Azure. Now, it's not been overnight. Microsoft has been working on this for a while now. And you can see the timeline here back to 2014 when Satya Nadella first announced that Microsoft loves Linux, all the way to 2018 and current, where Microsoft created its own Linux distribution and kernel for Azure Sphere. And what this really means is Microsoft loves you. Microsoft wants to meet you where you are and help you run your workloads, Microsoft-based or otherwise, with great performance, reliability, and security in Azure. And that is further underscored by Microsoft deploying bare metal, purpose-built hardware in the Azure data centers for specific workloads, including NetApp hardware, Cray supercomputers, SAP designed hardware, and now VMware. Azure offers the largest scale SAP HANA machines in the cloud. Azure is the only cloud that offers single node bare metal hardware to 24 terabytes of RAM while also providing lower cost SAP HANA certified virtual machine infrastructure. And running your SAP workloads in Azure, you can easily take advantage of other additional services like Azure machine learning capabilities or even Power BI over your SAP HANA systems. I mentioned VMware. You can take your on-premises VMware vSphere stack and just run them in Azure. Now, thus far, we've talked about performance and scale, but we also need to consider reliability and high availability. And Azure is the only provider with single VM service level agreements. If you are running your workloads on a single virtual machine, you will get a 99.9% SLA. However, failure and downtime can occur. Hardware fails, bugs in software exist, and in the lowest levels of Azure, there's a concept of fault domains and update domains. You can think of a fault domain like a single point of failure. So imagine a rack of servers. In that rack, there's a single top of the rack switch or power unit. If those fail, the rack will have downtime. Ideally, you would spread your workloads across multiple fault domains to increase reliability and availability of your workload. So imagine you have a web farm with several VMs. You would like them deployed across multiple racks or fault domains. In addition to failure, updates need to occur. And sometimes those updates require a reboot of the virtual machine or hypervisor. And in this case, Azure has a concept of update domains. And like fault domains, you want your virtual machines to be spread out across update domains, so they are available even during planned maintenance. Azure has a capability called availability sets. This lets you protect your workloads from outages, from hardware failures, or even updates. The way it works is you add your clustered or network load balanced VMs to an availability set, and then Azure can manage the placement of those VMs across multiple fault and update domains to optimize the availability of that workload. There is also a concept of availability zones in Azure. Like availability sets, availability zones provide low latency, high availability for your workloads, but instead of across racks of servers within a data center, it spreads your servers across multiple data centers within a region. Some Azure regions have availability zones, meaning there are multiple data centers within the region that are distributed, but still close enough that they have low latency communication between them. Availability zones protect your workloads from an entire data center outage within a region. Using availability zones provide even greater 4.9 SLAs. There are 54 Azure regions around the world. You can achieve even higher availability and HADR for your workloads by utilizing these regions for failover, and even load balancing globally across these regions. Azure Site Recovery is a service that will replicate your virtual machines in an application crash consistent manner so that you can easily fail over from one region to another with minimal data loss and recovery time. Management, operations, governance, and cost management is very important in any environment, including cloud environments like Azure. Azure Resource Manager is an infrastructure as code management plane that enables you to describe your environment, infrastructure resources, and their configurations in JSON documents. Then you can deploy entire groups of resources rapidly and consistently through these ARM templates. Azure provides scripting support to both PowerShell and Bash with a cross-platform command line interface. You can use these scripting tools on your local workstation or right in the Azure portal with the Azure Cloud Shell. To further configure the OS and application servers within the OS, you can use Azure Automation as a PowerShell desired state configuration pull server and to centrally manage and deploy PowerShell DSC configurations. And you can orchestrate automation in your environment using Azure Functions, Logic Apps, and Azure Automation Runbooks. You also need to understand what is happening across your data center, whether it's in Azure or on premises. Azure Monitor provides that centralized log and metrics storage, as well as management so that you can query, visualize, and alert on events that are occurring across your workloads. I mentioned Azure Site Recovery earlier in the context of high availability and HADR. ASR makes it simple to replicate your VM workloads to other Azure regions. And then in the event of a disaster, you can fail over your servers to the other Azure region. Azure also provides a backup service that you can use to backup files within a virtual machine or capture an application crash consistent backup of the entire virtual machine. Within Azure Backup, you can set up retention policies for grandfather, father, son style rotation strategies. Ensuring that members of your team and organization comply with guidelines and standards is very important. For example, you might only allow virtual machine workloads to be deployed into specific regions, and you might only allow certain virtual machine sizes, and you might require a naming convention for those virtual machine names. Azure provides several capabilities to help you govern your Azure environments, including management groups, which let you organize your resources. Azure Policy enables you to define the policies that you want to enforce in your organization, and you can apply these to your Azure subscriptions to ensure that your infrastructure is compliant with your organization's guidelines and conventions. Blueprints provide a way to group your deployment artifacts and apply them to subscriptions in a repeatable manner. Azure Resource Graph lets you query and analyze your resources to provide you with visibility into your Azure environment. And the new cost management capabilities help you monitor and govern your cloud spend. Security is a top concern in the technology industry. Microsoft invests more than $1 billion a year and employs more than 3,500 security experts to ensure your information is protected. Built-in Azure services like Azure Security Center help you protect your workloads and infrastructure from threats and exploits. Microsoft receives trillions of signals a day from more than 1.2 billion devices with more than 750 million Azure account authentications. This unprecedented volume of data gives Microsoft and Azure a unique edge and level of intelligence to help you protect your workloads. Azure provides several services to help us secure our environments, including DDoS protection, web application firewalls, network firewalls, as well as micro-segmentation capabilities within our networks using network security groups and service endpoints. Azure Security Center is a service built into Azure that provides unmatched hybrid security management and threat protection. You can quickly assess your security posture with the Azure Security Center Secure Score, which provides prioritized recommendations for improving your security posture. Azure Sentinel is a cloud-native SIEM that provides a bird's-eye view across the security operations of your enterprise. Using artificial intelligence in Azure Sentinel, you can make your threat detection smarter and response faster. In addition to security, we often have to adhere to regulatory and compliance requirements. Azure is the most trusted and compliant cloud. Azure has more than 85 compliance certification offerings that are industry-specific across health, government, finance, education, manufacturing, and more. These compliance certifications include HIPAA, FedRAMP, and PCI, amongst many, many others. In my role, I get to work with lots of companies around the world. I get to see lots of different drivers and catalysts for them to adopt the cloud and to migrate workloads to the cloud or to build new solutions in the cloud. And you'll see some of these right here. Common scenario is just the data center contracts that they have are expiring, and so they're considering different options and maybe more innovative solutions than what they currently have. Maybe they're acquiring companies rapidly and they need to onboard all of these services and infrastructure into their environments. They can quickly do that potentially in the cloud. Sometimes they're just out of capacity, and so they urgently need to scale. Sometimes it's just software and hardware refreshes that are catalysts. We often see increased security and compliance as a reason for customers to adopt the cloud. It's just a rapid way to meet those compliance demands and achieve the security that their customers are expecting. And when customers are building net new applications and innovating their applications, we see customers building those solutions in a cloud-native, cloud-first way. And sometimes software is just end of support. So much like software and hardware refreshes, the software is end of support, and so they have to drive into a software refresh. So there's lots of different reasons why customers and companies adopt the cloud and build their workloads in the cloud. The journey that customers take often looks like this. They will often take an existing application or workload and rehost that and migrate that in the cloud. That's a very simple, low-friction way to get started. Then over time, if it's an existing workload, they will refactor that and take advantage of the cloud. And sometimes they'll re-architect those solutions completely. If it's a net new application, or if they have the opportunity to rebuild that application, they will often start with a cloud-native approach and start thinking about things like those PaaS services we talked about earlier. And in some cases, they're just looking to replace solutions with SaaS offerings like Dynamics 365. So this is a common journey that we see customers taking in their cloud journey. They often start by assessing their workloads. There's tooling out there to help you assess on Azure.com in the Azure Migrate Center. And you can assess your workloads to figure out how those map to Azure. What is supported, what levels of compute might you need for your VMs. And then you can start to migrate. You can use services like Azure Site Recovery to help you with your migrations and a lift and shift sort of migration. The Azure Database Migration Service is also a great service to help you migrate. And then over time, you optimize those solutions in the cloud, again, bringing in those cloud-native capabilities. And you also want to, along the way, make sure that you're securing and managing those solutions well using services like Azure Monitor and Azure Security Center. I talked a little bit earlier about end of life of software support being a catalyst for customers to migrate to the cloud. And this is one of those scenarios. You'll see here Windows Server 2008 R2. End of support date is January 14th, 2020. You'll also see SQL Server 2008 R2. The end of support date is July 9th, 2019. So those are catalysts and reasons customers maybe rehost and re-architect their solutions in the cloud. They have to touch those solutions anyway. They have to upgrade those servers, and it's a great time for them to consider maybe getting those workloads out of their on-prem data centers into the cloud. There are also extended security updates in Azure, so you get 3 years of security updates after the on-premises support ends, and 75% of the license cost to buy standalone or for on-premises servers is available for Windows Server and SQL Server in Azure. There are also some opportunities for you to save some cost in Azure. There's the normal pay-as-you-go pricing, but if you make a commitment to 1 year or 3 year commitments for your resources in Azure, you can also get reserved instance pricing, and that will dramatically reduce the cost over pay-as-you-go. You can add on to that Azure Hybrid Use benefit, which is really the ability to repurpose your on-premises licenses in Azure and leverage them in both places, and that will also save you significantly on the pay-as-you-go pricing. You can see an example of this by looking at the comparison of running these workloads with reserved instances, hybrid use benefits, and those security updates in Azure versus AWS. The analysis shows it is a 5 times cost increase to run those workloads in Amazon instead of Azure. In summary, Azure provides modern infrastructure services for all of your workloads. With built-in hybrid support enabling you to extend your on-premises data centers into Azure, and security and management capabilities integrated into the foundations of these services. All of this while being economical and cost-effective.